Hello, calculus student. This video is for chapter 2.1. We want to talk about how to find area between two curves. I'll do two examples, and then further example will be in the second video. Before we start to find area between two curves, I want to review how to find area below one curve above the x-axis. Now, the definite integral that we use can be used to find net area, which means area that is positive above the x-axis, negative below the x-axis. So if you are to find area, meaning this is always positive, we want to make sure that f of x is always above the x-axis. If it's below, you have to adjust it by finding the absolute value or multiplying the area by a negative number. So let's do an example. So for area below f of x but above x-axis, you want to make sure that your f of x is always above the x-axis in this interval, right? AB. Then the formula for it would be, you would cut a small rectangle, and then the small rectangle's height is f of x. The bottom is dx, so it turns out you would add all of this small rectangle together. The area is f of x dx. Integral AB f of x dx, which by fundamental theorem of calculus can be found by the antiderivative of a small f of x b minus the antiderivative plug in a. Right now, if your function f actually fall below, like for example, this is AB, but then there's some part that fall below the x-axis, so you would need to make sure that you recognize that this is negative, and then do the absolute value, so you will add the top and the bottom. Or better still, if your f of x is actually like this, right, which is our second example, then to find the area between the x-axis and the f of x, you would have to say, okay, so this is any area below it, or any definite integral that I found would found it as a negative area. I have to do the absolute value or multiply by a negative one to get it to be a positive number. Okay, so let's do one example. This example is find the area under f of x squared plus 5, but above the x-axis. So in all cases, when we find area, we want to make sure that we sketch the area or sketch the graph. X squared plus 5 is a transformation of y equal to x squared, which is the parabola. At 5 means it's a parabola up 5, right, with the vertex at 5 here. Don't know why this has this thing. So it will be 5 here. And then, but above the x-axis, the x-axis is y equal to 0, so it's this one. And in the interval, 1, 4. So I know the interval. Okay. So this interval is 1, 4. F of x is above the x-axis. I don't have to worry about negative or anything. So the area would equal to integral 1, 4 my f of x, which is x squared plus 5 dx. I think we review it in calculus 1 review. So do the antiderivative will be x cubed over 3 plus 5x evaluated from 1 to 4. So that means 4 cubed over 3 plus 5, 4. Subtract 1 cubed plus 5 times 1 is 5. So I would have 64 over 3 plus 20 minus 1/3 plus 5 will be 15 over 3, 16 over 3, right? And this would be 60, 124 over 3 minus 16 over 3. So that is equal to 24 minus 16. Let me get my calculator. 124 minus 16 is 108, but it's divisible by 3. That's 36. So that's typically what we do if we are doing the definite integral by hand. So the second question would be find the area between the x-axis and this graph. They don't tell us if this is on top or where. They just want to find the area. And then there is also no intervals. In this case, we actually have to graph it and figure out where the areas are. Do they have two intersection or one intersection or something? So so this is x squared minus 2x. We know is a up parabola. And to graph it, how do I do? I would see that I can factor it and find the x-intercept, because if I don't know where they cross, I don't know the area that they bound. So I'll find the x-intercept by setting y equal to 0. Y equal to 0 means 0 equal to x squared minus 2x. To solve it, I would factor the x out, x minus 2, and then split it as x equal to 0. Zero product property x equal to 2. So I know to graph this, it would be like this. This graph is like x equal to, how come it's always have those things? This is a 0, and this is a 2, and this is my f of x. My x-axis is here. The area between them would be this. It turns out that the x-axis is at the top, the y-axis is below, right? So if I do the integral of just x squared minus 2x from this 0 to 2, I will have a negative area, because the definite integral give net area, which is subtracting the negative area. So if I actually want to find the area, I would need to multiply a negative 1 to it. So I would force the negative to be a positive dx, right? So that's what I'll do if I see this is below the x-axis. So so let's do the x cubed antiderivative minus 2x squared over 2. Okay, the negative is outside, and I want to evaluate from 0 to 2. So that would equal to 2 cubed, which is 8 over 3, negative outside still, minus 2 and 2 cancel, 2 squared, which is 4. So it would be negative 8 over 3 minus 12 over 3. So there will be negative 4 over 3, but negative of it will be 4 over 3. So that is the actual area between the graph and the x-axis. So this illustrates that if you don't have the interval given, you would have to find the point of intersection of the curve and the x-axis. And if it is below the x-axis, you have to do a negative to find the actual area. So we are ready to find area between two curves. So we use the same argument that we used to find area, which is to adding all these small rectangles together. Now, each one of these small rectangles will have a height of not just f of x, but f of x minus g of x, because the area between f and g, for the time being, we assume that f is on top of g. So this would be the height of one rectangle, or a representative rectangle will be f minus g, and then times the width of the rectangle is dx, which can be converted into by the Riemann sum concept would become AB, f of x minus g of x. So this would give you the area of between f of x and g of x in this interval if f is greater than g in the whole interval, right? In the whole interval AB. We don't care if it is greater than it later, because f can drop and g can go up, but in the whole interval, f is greater than g. So what happened if it is not, if f is below g in some case, or if I don't have an interval given? So we'll talk about this in case C and D. Okay, so this is the how-to. First and most important is to sketch the graph of f and g. So this gives us a chance to see when they cross, and also if f and g is above, f is above g in the whole interval of AB if given. And if we have no AB given, we can also solve or get an idea on when f and g cross. Then the area would be the two places where they cross, and with f minus g if f of x is greater than g of x in AB. So this was with the perfect case when we just want to know FG. This is F and this is G, and this is the area between them. And we would find their, so this would be our finding of AB. We determine AB ourselves, and F is above G. Some case you actually have AB given, but you don't know F and G is always one is above the other. So for example, I have AB, but F cross G. So F is above G in the first part, but G is above F in the second part. In this case, we would have to find the area one by one, or find the absolute value of F minus G using multiple definite integral, meaning in the second one you have G minus F, in the first one you have F minus G, having the area between A, B, but this is C, so you do A to C, C to B like that. Okay, so I'm going to do an example 2 and 3, which are simple case for area between two curves. So example 2 is finding the area bounded by f of x and g of x bounded above by f of x plus 4 and below by g of x 3 minus x over 2. So they hint you that f of x is always above, g of x is always below, but to be safe, you should always sketch the graph. So let's sketch f of x, which is a line with y-intercept equal to 4, and slope is 1. That means 1 over 1. So it would be a line like this. So write as f. And then this the second line, g of x is 3 minus x over 2, is also a line. The y-intercept is 3, just below the f, but the slope is negative 1/2, because negative x over 2 is negative 1/2 x. So you would down 1, run 2. So you can see that it's a graph like this. This should be just a line, okay, not curving. Like this. So that's G. You can obviously that F and G go to different direction, and in the interval of 1, 4, they never like cross. So this would be the area between the two graphs. So please sketch it. I will require you to sketch the area when you find area between two graphs. So how do I find the area between them? So in a representative rectangle would always have F minus G as the height, and the width is dx. So we would say the area is equal to 1, 4 F, which is x plus 4, parenthesis minus G of x, 3 minus x over 2. So make sure that you do parenthesis 3 minus x over 2, because once you simplify, it would actually become x plus x over 2 is 3x over 2 plus 1 dx. Now we want to do the integral 3 over 2 x squared over 2, right? X squared over 2 plus 1x, evaluated from 1 to 4. Okay, so be 3 over 4 x squared plus x, evaluated from 1 to 4. So let's plug in 4 first. So be 16. 16 times 3 over 4 would actually be 12, right? Plus 4. Subtract 3 over 4 plus 1. So that is 7 over 4. 16 minus 7 over 4. Convert it into improper. 64 over 4 minus 7 over 4. That is equal to 57 over 4. Second, the third example is about area of the shaded region. So the two regions have a f of x of 9 minus x squared over 2 is a down parabola. And then g of x is a 6 minus x. You can obviously see that f is above g. They cross at 2 points. And in the question, they just say find the area of the shaded region, which is from the two crossing. So you can read off the crossing, but it's not an accurate graph, so you don't really know exactly what it is. To find the point of intersection, you will have to solve the equation point of intersection, because the point of intersection would be your interval. You would have f equal to g, right? Because f and g have the same y. So 9 minus x squared over 4, x over 2 squared is x squared over 4, equal to 6 minus x. Multiply everything by 4 because I want to clear the denominator. It will be 36 minus x squared equal to 4 times 6, 24, minus 4x. Move everything to one side where the x squared is positive, so I will leave this as 0 and plus x squared on this side, minus 4x, and then minus 36, so it becomes minus 12. So to solve it, I can do the diamond method. This is x squared multiply to be negative 12. Okay, multiply negative 12, add to be negative 4, so it'll be 2 and 6, right? So it'll be x minus 6, x plus 2. And then I split them, it'll be x is equal to 6, x equal to negative 2, which makes sense. This point of intersection will be negative 2, from negative 2 to 6. So our area would be from negative 2 to 6. Always the top is 9 minus x squared over 4 minus 6 minus x, and then dx. So then, let's erase this, get some more space. So I want to do this by hand, so I would do the 2, 6 combined like terms, so negative 1/4 x squared. For the x term, I have plus x. For the constant term, I have plus 3. So I'm going to do the integral. The integral would be a equal to the antiderivative. Oh, this is minus 2, from negative 2 to 6. Negative 1/4, and then x cubed over 3 plus x squared over 2 plus 3x. So it will be negative 112 x cubed plus 1/3 x squared plus 3x. Integrate or substitute from negative 2 to 6, from negative 2 to 6. So let's plug in. So that's equal to a. So let's plug in 6 first. So negative 12, 6 cubed plus 1/3, 6 squared plus 3 times 6. So this whole thing minus negative 112, negative 2 cubed plus 1/3, negative 2 squared plus 3 times negative 2. Okay, so you evaluated this. 216. Okay, so 6 cubed is 216, but divided by 12 is 18. So the first is negative 18 plus 8. Is this a 1/3, 1/2 or 1/3? Oh, this would be 1/2. Oh gosh, this is 1/2 because it's x squared over 2, right? Yeah. This is 1/2. This is plus 18. Oh, this is 1/2 also. And then plus 1, 18 is minus. So this 2 cancel. The first part has 18 only. So this would be 8 over 2, negative 8 over negative 12. So it'll be 8 over 12 plus 2 minus 6, right? Because this is 2, so 4. Simplify 2 over 3. 2 over 3 minus 4. So that would equal to 18. 2 over 3 minus 4. Negative 10 over 3 plus 10 over 3. because it's negative 10 over 3 is a subtract, so it will be 54 over 3 plus 10 is 64 over 3. So that is the area between the two, and in the next video we'll do 4, 5, 6, 7. These are the different cases where you would have the curve being a trig function, and then they cross each other. And this one I don't know. They also not given AB, so we have to find the intersection. And example 6 also we don't know where they cross. Example 4 would be e of x, and then but we were given the interval. Okay, so watch the next one for more example. But these two are the basic one. You basically were given an interval, and the best case is f is above g, or you were given two graphs. You just want to find the intersection and find the area between them.